guys, so today we're going to talk about ratios, and the first thing we need to know that ratio is a comparison of two numbers through division, and this 2 is so important because you literally can have two numbers. Now, that being said, sometimes they can be improper fractions. All right, so they can be improper fractions. Now, there are 3 ways to write. One is using the word 2. The other is the colon key, and you can find that beside the L key on your keyboard. And then as a fraction. Now, right here, this is probably one of the most important pieces of this ratios, is whatever they ask for first, you have to write that number first. And whatever they ask for second, you have to write that number second. So that is extremely important. Alrighty, so going over here, let's looking at 3 examples of how to write these, and we're going to write them in all 3 ways. So it doesn't really matter whether you do the fraction first, the colon first, or the word 2. We just need to make sure that we do all 3. So looking up here, this is our sample space here. If you look, they want to know squares to circles. Well, how many squares are there? There are 3. And how many circles? There are 5. So our ratio is 3 to 5, 3:5, or the fraction 3/5. It all means the same. And again, it doesn't matter the order. Now, when you go to write a ratio of stars to triangles, you need to remember to put the star number on top. And yes, it's going to look like an improper fraction, but that's okay. We'll come back to him in just a second. So it's 4 to 2 and 4 the colon in 2. Now, yes, some of you realize right off the top of the bat, hey, we can simplify that, and you're absolutely right. Remember that with ratios, though, you have to have 2 numbers. So while we can divide both of those by 2, the ratio would be 2 to 1. And yes, you have to put that 1 underneath of it. That kind of is where the trick comes in, where we want to go to 2, but we can't. So it's 2, 2, 1, and then 2 colon 1. All right, and our last example in this spot is triangles to total shape. Now, we know that there are 2 triangles, but how many do we have altogether? And that does include the triangles. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So you have 14 total shapes. Yep, you're right. We can simplify that to 1 to 7. So here's our fraction, and we want to simplify it. And then we want to use the word 2 as well. Oh, that should be a 1. Sorry. 7. Very good. Now let's look at boys, girls, and adults. So there are 7 boys, 4 girls, and 2 adults. So what is the ratio of girls to adults? Well, that's 4 to 2. Again, it can be simplified 2 to 1. Remember, you got to have 2 numbers. And you have 4 over 2, so that's 2 to 1. And then 4 colon 2, oops, sorry. Very good. Now, what is the ratio to total people? Well, we got to add these up, so the total number of folks is 13. Sorry, guys. So we have 7 boys to 13. Now that can be simplified. Very good. So now we want the ratio of students to adults. And how many students are there? How are you going to find that? Well, you're going to add the boys and girls together. And that is 11. So you have 11 students to 2 adults. So that's 11 colon 2 and 11 to 2. All right, so that's ratios. Now let's talk about equivalent ratios. Equivalent ratios are just ratios that say the same thing, only using different numbers, meaning that they're same, and when we simplify them, they all come to, they're the same proportion. All right, and equivalent right here, that's just a fancy word for same, and we need to start using that word when we hear it, because we're 6th graders now, and we want to use our big fancy words. Alrighty, so let's look at our chart. They've given us a ratio here, and we want to simplify it. Remember, simplify it is also known as lowest terms. So that's 3 to 5. And then equivalents, we can sometimes go bigger. For example, 12 to 20, 18 to 30, 60 to 100. And again, there's more. We're not going to list them all, but we're going to list a couple. So for the next one, you have 7 to 4. And what would our equivalent ratios that are bigger be? Well, you could have 28 to 16, 42 to 24, 140 to 80. So when you simplify this one, there's a lot that we can do to make it a little smaller. For example, 10/25 or 4/10. But really, the simplified version is that guy right there, 2/5. These could be considered equivalent as well. But they're all simplifying, they're all getting smaller, but this is the simplest form, that 2/5. So what are some bigger equivalents? Well, 40 over 100, 200 over 500. There are others, but we're going to just do those two. So here you have 3 to 9. Well, that simplifies to 1/3. So what could we have as equivalents? So that's 6 to 18, 9 to 27, 30 to 90. And again, there is a bunch more. So like 20 over 60, that would be considered one. Alrighty, and our last example is 15 to 20. That's going to be 3 to 4, because you can divide both of those by 5. And you have 18 to 24, 12 to 16, sorry, there's my dots, and then 9 to 12. And those are your equivalent ratios. Bye.